Let's start. All right. Okay. So I will skip the rules because all of you are regular. This is just a reminder. All right, go and read through yourself. Okay, let's start from last week's 3 questions. Okay, so these are very factual things, so I'll just flash. All right, so but looking at this, can you all type in the chat which is the lightest? Which is the lightest subatomic particle? Okay, we have PM, pen, right? PN is an English word, pen. You use a pen to write on a paper, pen. So which particle is the lightest? Thank you, Larissa. The rest, looking at the mass. All right, so therefore, thank you, Saron. So this is the lightest. Okay, so electron is the lightest. It's almost 0 gram. All right, lightest. Okay, then for proton and electron, let me switch to a different color. Sorry, proton and neutron. Now, proton and neutron are all inside the center nucleus, right? Okay, nucleus is in the center. Okay, so notice that the mass is all 1 and 1. Okay, let me admit someone. Just a minute. Hi, Kiran. Okay, let me mark your attendance first. Kiran. Okay. Okay. Larissa asked a question. Why is it 1 for this one? Now, for electron, right? Some textbooks will write 1/1836, or you can write 1/1840. Up to you. You can write either the 4-digit number 1836 or 1/1840, because if you round up to, a 3 significant figure, it'll be 1840. All right. So this is just how accurate you want it to be. Okay, so it's 1 divided by 1836 is accepted, or 1 divided by 1840 is also accepted. So electron is the lightest. All right, we all hope that, as we eat a lot of nice food, we will remain like the electron, the lightest, even though we eat a lot of nice things. All right. Now for proton and neutron, those that are found in the center nucleus, if I were to put them on a seesaw, I'm sure you have played seesaw before. All right, proton is a positive charge. If I put 1 proton on one end of the seesaw, now the neutron will be at the other end. It will be equal mass. It will balance. All right, so the mass of 1 proton, okay, mass of 1 proton is exactly equals to mass of 1 neutron. All right, so that is the meaning why they have the same number. Okay, same number. Think of it as if it's like 1 gram and 1 gram. Of course, it's impossible. Proton and neutron are so small. The actual mass will be 0.0000000. Don't know how many gram. All right, it'll be a very small number. It cannot be 1 gram. Right, because proton is so small, neutron is so small, electron is even smaller. All right, so this 1 and 1 is just a ratio. All right, so when you see 1 and 1 for the mass, it simply means 1 proton will weigh the same as 1 neutron. Is everybody clear? All right, then what if I have a seesaw? Okay, let me do in red now. Let's say I have a seesaw. I want to balance my seesaw. If one side it is 1 proton, all right, just 1 proton. Can you tell me how many electron is negative charge? Can you tell me how many electrons must I put on the other side to balance the seesaw? Everybody type into the chat. Yes, Shen, please help yourself. All right, I will admit you later. Okay. Larissa is your number 2. The rest, what do you think? How many electrons must I put here to balance the seesaw? The other side is only 1 proton. All right. Okay, no worries if you've gotten it wrong. Actually, the number is you need 1,836 electrons. All right, or 1,840, depending on, okay? So either 1836 or 1840 electrons, right? To balance the mass of 1 proton. All right, so everybody clear? Okay, reason being, electron is so light. All right, so electron is very, 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 very light. So you need so many of them. So imagine if I were to draw it out, I will draw a lot of E minus. I'm not going to draw 1,000. All right, I'm not going to draw 1,800 electrons, but you get the picture. All right, I will have to draw many, many electrons just to balance 1 proton. All right, so this is just one proton. All right, so over here you have 1836 or 1836 electrons. Okay, you can also see as 1840 lah, but I don't want to confuse you. All right, so the mass of one proton is equals to 1836 electrons, the total mass. So you will need to have a lot of electrons together, all right, huddled together. So many electrons on one end of the seesaw. The other seesaw is just one proton. All right, so this is telling you electron is really, really light. All right, electron is so light. That's why you need to put 1836 electrons together just to balance one proton on the other side. So is everybody clear? Anybody not clear, please let me know. All right, let's move on then. Okay, hang on. All right, so this one is explain what A, Z, and X are. So A is mass number. So let me just give you a memory aid to help you remember. Do you see there's an A here and an A here? All right, so this is a memory aid. Okay, then Z is a proton number. Okay, so if you're wondering what is mass number, so mass number, everybody tell me PEN. Protons are positive charge, electrons are negative charge, neutrons are got no charge, one zero charge. Can you tell me which ones are the ones who contribute to the mass? Everybody type into the chat. Who contribute to the mass of an atom? How heavy an atom is depends on which one. Does it depend on proton? Does it depend on electron? Does it depend on neutron? Or does it depend on two of them or all three of them? All right, can everybody type into the chat? Mass is contributed by who? How heavy an atom is contributed by which one? All right, well done, Ais. All right, so we have a pen, P-E-N, pen. All right, so protons are positive charge, electrons are negative charge. Larissa, not all, because remember, electrons are really the lightest. So think of electrons as almost zero mass. Of course, an electron has some mass, but it doesn't contribute significantly. Yijian, not just proton. Remember, proton and electron has the same mass. So proton and neutron. All right, so proton and neutron, same mass. So if I put one proton on the left, I will put one neutron on the right. Proton and neutron same mass. All right, so mass of one proton equals to mass of one neutron. All right, so electrons are the lightest, almost zero weight. So electrons are really, really very light. So electron does not contribute to the mass so much. It contributes a little bit only. Electron does not contribute too much to the mass. It is proton and neutron that contributes a lot to the mass. And both of them you must say because they have the equal mass. So the mass of one proton equals to the mass of one neutron. They have equal mass. All right, equal mass. So these two, P and N, contribute to the mass. All right, so you will remember it by P and N, the first letter and the last letter of pen. All right, so you just remember as pen. All right, so this one and this one. All right, so P and N, okay, will contribute to the mass. All right, contribute to the mass of the atom, how heavy the atom is. Depends on how many protons you have, how many neutrons you have. Therefore, here mass number, it is actually, all right, protons, all right, plus how many neutrons you have. That will contribute the mass. All right, if you find it difficult to remember, just remember the first letter and the last letter of pen. So how many protons you have, how many neutrons you have, add them together, that will give you the mass number. Mass number means how heavy the atom is. Is it a very heavy atom or is it a light atom? All right, so it depends on how many protons you have, how many neutrons you have. All right, then for this proton number will just be how many protons you have, P plus. Okay, and X is the chemical symbol. All right, so if you take a look here, do you see this part? This is the real periodic table you'll be given in the chemistry exam in 4 O level. So if you look at potassium, I have enlarged it. All right, I enlarged it. So can y'all look at these two numbers, 19 and 39? Can you tell me which one is the mass number? 19 or 39, which is the mass number to tell you how heavy the potassium atom is? how heavy it is it 19 or 39? Larissa, well done. The rest, 19 or 39, which one gives you the mass number? How heavy the atom is? Mass number. So which one is mass number? Yujie is the opposite concept. All right, but good try. The rest, Alice, well done. Saron, opposite concept. Good try. The rest, please try. Which one gives you the mass number? Which one tells you how heavy the atom is? All right, so this one will be the mass number. It tells you how heavy it is. All right, it tells you how heavy the atom is. And mass number is contributed by the number of protons plus the number of neutrons. First letter and last letter of 10. All right, then 19. All right, you have forgotten the smaller number. Do you remember your PEN? All right, protons, electrons, neutrons. Can you tell me how many protons, how many electrons, and how many neutrons? Can you write 3 numbers? That means fill this up. How many protons, how many electrons, how many neutrons in one potassium atom? Right, give you all 5 seconds to type your answer. Just type 3 numbers for me. How many protons, how many electrons, how many neutrons? Just type the 3 numbers. All right, 5, 4, 3, 2, 1. Okay, type 3 numbers out. How many protons, how many electrons, how many neutrons? Okay, Larissa, last one is wrong. All right, so y'all have forgotten this again. All right, well done, Larissa. You have made the change. Well done. The rest, can you please try? So I already told you the smaller number, copy it 2 times. I copy it 2 times. Yujie, well done. But then you must, the only thing is your pen is not in the right sequence, so I have to read carefully. So only the last one you do calculation. So 39 minus 19, that will give you 20 neutrons. All right, so you copy the number 2 times. All right, so this is what I mean. Let me put in yellow highlighter. Take the smaller number, copy it 2 times. All right, take the smaller number, copy it 2 times. So the smaller number will tell you how many protons, how many electrons. So 19 protons, 19 electrons. Then 39 tells you how heavy the atom is. Think of it as if it's 39 grams. Although it cannot be 39 grams. Now, one atom is so small, how can it be so 39 grams? It'll be a much smaller number. But think of it as if it is 39 grams. So 39 grams is made out of the protons plus the neutron. Together, it gives you how the mass. Because T and N contributes to the mass. Electron is so light, electron is almost weightless. All right, so electrons are very, very small. They are very weightless, right? So P plus N equals to 39. If you know P is 19, this is 19. So 19 plus what give you 39? So to get this, you will use 39 minus 19. That's how you use big number minus small number. It gives you 20 neutrons. Is everybody clear? Because we really don't have so much time to keep revising this part. This is atomic structure. All right, structure of an atom, PEN, copy the number 2 times. The last one, big number minus small number. All right, so 19 protons, 19 electrons, 20 neutrons. All right, so big number is the mass number. It tells you how heavy the atom is. Small number is the proton number. All right, small number is a proton number. So let me write here, this is proton number. All right, so let me just highlight. So small number is proton number, then the big number will be mass number. Okay, the big number is mass number, which is protons plus neutrons. So number of protons plus number of neutrons will give you 39. All right, any questions so far? Okay, if not, then this is what we do. A minus Z, big number minus small number will give you number of neutrons. All right, use a big number minus small number. Let's move on. Next question. Suggest an instrument used to measure the thickness of the wall of the tube. Now here says that thickness of the wall is 3 mm. 3 millimeter is really very, very, very small. Can everybody type into the chat what instrument will help us measure the thickness of this tube?